What is the coldest thing in the universe? You might think it's deep space, or a distant frozen planet, but the coldest place ever recorded isn't out there. It's here, on Earth. Now, let's start with space, because it does feel like the obvious answer. If you travel far enough away from stars, planets, and any sources of radiation, you reach what's known as the background temperature of the universe. That's about -270 degrees Celsius. Colder than anything we naturally experience on Earth. Colder than Antarctica. Colder than liquid nitrogen. But even that isn't the coldest possible temperature. There is a limit. A point where temperature simply cannot go any lower. It's called absolute zero. That's -273.15 degrees Celsius. And at this temperature, atoms lose almost all of their energy. They don't just slow down, they effectively stop moving. No vibration, no motion, no heat. Absolute zero is the baseline of all temperature in the universe. So space is incredibly cold, and absolute zero is the limit. But here's where things get interesting. Scientists have managed to get closer to absolute zero than anything naturally occurring anywhere in the universe. Inside highly controlled laboratories, scientists use a technique called laser cooling. It sounds completely backwards, because we usually think of lasers as something that heats things up. But in this case, they do the opposite. Atoms are always moving, and that motion is what we experience as temperature. So if you can reduce that motion, you reduce the temperature. Scientists fire carefully tuned laser beams at atoms from multiple directions. Each photon of light nudges the atoms slightly, slowing them down bit by bit. Step by step, those atoms lose more and more energy, until eventually, they are barely moving at all. At that point, they are just a tiny fraction above absolute zero, colder than anything naturally found in space. And then something really strange happens. At these extreme temperatures, atoms stop behaving like individual particles. Instead, they begin to act together as a single quantum system, almost like one giant atom. This state of matter is known as a Bose-Einstein Condensate, and it's one of the few times we can observe quantum effects on a scale we can actually study directly. So why go to all this effort just to make something incredibly cold? Because at these temperatures, the normal rules of physics begin to blur. Scientists can study quantum mechanics with incredible precision, unlocking insights into how matter behaves at the smallest scales. This research is helping to drive advances in things like quantum computing, ultra-precise sensors, and our fundamental understanding of the universe itself. So the coldest place in the universe isn't a distant corner of space. It isn't a frozen planet. It's a laboratory, built by humans, right here on Earth. And it exists just a fraction of a degree above a temperature where motion itself comes to an end. If we can get this close to absolute zero, what other limits of physics do you think we'll break next?